Okay, Assalamualaikum and good morning. So this is a guideline for experiment 1, experiment capacitor. So look at objective of the experiment. So first you have to determine what is time constant tau and to determine the capacitance of the capacitor C1 and C2. So continue with the data tabulation. So data analysis, please copy back the data given on your Google Classroom. Okay, you have two tables. First data for single capacitor C1 and the other's data is for parallel connection between C1 and C2. So you have two table. Copy and complete that table. Okay, next is plot graph I versus T. Okay, after you copy the table, so make sure plot graph I versus T included with unit for each axis. Okay, so you need to sketch the graph, both graph on the same axis. So you can see here, I have two colors of the graph, the green color and the pink color. So the green color is contribute for C1 and C2 connection in parallel, and the pink one is for C1. As you can see that the theoretical said when the capacitor more bigger or more larger, so more larger capacitors means that need more time to fully charge or fully discharging for the capacitors. Okay, as you can see here, the value of tau 1 is more smaller than tau 2 because the value of capacitor tau 2 is bigger than capacitor 1. Okay, as you can see here, how to get tau 1 and tau 2 means that time constant 1 and time constant 2 is depending on the value 0.37 from I0. Okay, for example here, I give it to you. If let's say I0 is 100 microampere, so 0.37 from I0 is represent 37 microampere. So you have to determine which part of the 37 microampere and then draw the dotted line, passes through the exponent graph, and then you can determine tau 1 and tau 2. Okay, so the shape of the graph must be in exponent curve. So make sure that when you draw the graph with the smooth hand, not necessary pass through every point, but as long as you get the smooth curve is okay. Alright, so next, based on the related equation, so tau is equal to RC, time constant is equal to resistance times capacitor. So we want to calculate C1. We want to determine C1. So tau 1 is equal to RC1. Given resistance in this experiment is 100 kilo ohm. You substitute tau 1 from graph and divide it by R 100 kilo ohm. So you will get C1. After that, from tau 2, you can determine the capacitor 2. Because capacitor are in parallel connection is C12 is equal to C1 plus C2. And then tau 2 is come from graph. R is 100 kilo ohm. C12 is combination between C1 plus C2. Substitute C1 that you get from the calculation above and then you will determine C2. So next, for discussion, state and write the value of tau 1, tau 2, C1 and C2 that you get from calculation above and state the errors. Okay, for errors in this experiment, you can write the time taken might be greater than theoretical value due to the reaction time while starting the stopwatch. It depends on the individual. This is systematic error give a rise in percentage of the uncertainty. The other error is parallax error occur when taking the reading from the microammeter. Third one, capacitor is not fully discharged. Number 4, systematic error due to the connection of the wire. That's some example for problems or error occur during the experiment. Okay, next, for precaution step, make sure to start the stopwatch simultaneously when the switch S is opened. The eye of the observer should be perpendicular to the scale of the microammeter. Before starting or repeating experiment, make sure the capacitor are fully discharged by using a connecting wire to short circuit the capacitor. Make sure that the switch S is open and microammeter decrease until 0 when the short circuit the capacitor. Last one, check and repeat the reading and take the average value. You can choose 2 for each error and precaution step that I said before. Okay, next, for the conclusion, so you refer the objective. That's all. Thank you. Good luck.